Hello, Algebra 2A students. So today we are going to work with polynomials. Poly means many, and so generally we're looking at an expression or an equation or a function that has many terms. But what you need to realize is that each term will have a coefficient, which is the number that comes before the x or the x squared or the x cubed, and they'll have pluses and minus signs between them. Now the x's can only be like x to the first, x to the second, x to the third, x to the fourth. You can't have x's to negative numbers in polynomials, and you can't have x's to fractions or x's to decimals, because then they wouldn't be polynomials. Polynomials are very straightforward, which is why we like them. Now, I have gotten a series here in the left-hand column of polynomial expressions, and we're going to work with vocabulary around the expressions so you get used to how to talk about polynomials. All right, so the first thing we want to do is we want to look at the fact that on this first polynomial, it's 3x squared, 4x minus 5. Now, I could say that's x to the 0 because we know that x to the 0 equals 1. Normally, you're not going to do that, but you'll always, if you're writing the polynomials right, then you'll put them in descending order, which we're going to talk more about, where x squared is the highest exponent, x to the first is the medium exponent, and x to the 0 is the lowest exponent. So you always arrange it from high to low that way. That's called descending order. Now, once they're arranged in order from high to low, this term is called the leading term. And from the leading term, you're going to get the degree of the polynomial, which is the exponent. So the degree is always the highest exponent in the polynomial. You'll also get the leading coefficient, which is the number that goes with the x squared, and that's the 3. Okay? Now, on the middle term, 4 is your coefficient. And on the end term, 5, you could kind of say is the coefficient, but they're not the leading coefficient because they're not in the leading term. So if I want to describe this polynomial by degree, I'm going to say since x squared is the highest, it's quadratic. So we have words that you're used to for a couple of them, and then you'll learn some new vocabulary words. If I want to talk about what kind of polynomial it is by the number of terms, guys, 3x squared is a term, 4x to the first is a term, and 5 is a term. That's a total of 3 terms. If it's 3 terms, it's called a trinomial, which I know you've heard. But you all know that tri means, that prefix means 3, and bi is a prefix that means 2, like bicycle. And then mono is a prefix that means 1. So we'll talk about all of those. Now the constant term is the term that goes with the understood x to the 0. The constant term is just the plain number, and when you put them in descending order, it's always going to be the caboose. It'll be the last thing you write. Now, in your second polynomial, I see that there's a negative 5x to the 7th term and a 1 term. Terms are separated by pluses and minuses. Since there are 2 terms, I'm going to call this a binomial. All right, I see that the plus 1 stands alone, so 1, positive 1 is your constant term. Now this one's in descending order because x to the 7th is bigger than this understood x to the 0. Again, I'm not normally going to write x to the 0 in it. But if x to the 7th is bigger than x to the 0, then this negative 5x to the 7th should lead. So your leading term tells you the degree, which is 7, because degree is exponent, and the leading coefficient's negative 5. Now on this one, the degree being 7, we don't have a nice vocabulary term for that. So we just say that this is a 7th degree polynomial, and you'll see me abbreviate poly. So this 7th degree polynomial is a binomial because it's got 2 terms. So I could give it lots of vocabulary. Now, the next polynomial I see is actually a monomial. It's not poly because there's not many. So one term means it's a monomial. So is there any sort of number out here on the end that stands alone? No. So its understood constant term is just 0. There's no plain number there. There's not one. Now the degree is x to the 6th. It's just the exponent 6. The leading coefficient can only be 1/2 because that's the only number you've got in the problem, the only coefficient. Now x to the 6th, the degree, again we don't have a cute name for it, so we're just going to have to say this is the 6th degree polynomial. So if we have a 1st degree, 2nd degree, 3rd, 4th, or 5th degree, we've got names. 6th degree on and on up, you don't have names for the polynomial based on degree. Now, on my next polynomial, I see 8x to the 4th, 3x to the 7th, and 10x to the 9th. That's 3 terms. That's a trinomial. I don't see a plain number, so I'm going to say the constant term is 0. Now, I don't have it in the correct order. If I did put it in the correct order, 10x to the 9th would be first because it's got the highest exponent. So my leading term is 10x to the 9th, which tells me my degree is 9, and my leading coefficient's 10. And again, since the degree is 9, I don't have a neat name for it. So 6th degree and higher, there's no way to talk about it other than to say, well, it's a 9th degree polynomial. Now, on the next one, I see 3x is one term, 1 is another term. That's 2 total terms. That's a binomial. I do have a plain number. It's 1. So 1's my constant term. Now, 3x is definitely, it's not where I plan to write that, but that's okay. 3x is definitely my leading term. So it's x to the 1st power, and 3 is my leading coefficient. So anytime it's to the 1st power, I say that this polynomial is linear. Because think about it, if you put a y equals in front of this, you would have y equals 3x plus 1, which if you graphed it would be a line because it's y equals mx plus b form. So 1st degree polynomials are linear. That's the adjective we use. Now, on the next one, I see 1, 2, 3, 4 terms. I only have nice names for 1 term, 2 term, 3 terms, monomial, binomial, trinomial. For this one, I would just have to say it's a 4-term polynomial. I think I got a little extra going there on my M. Got a little overzealous, I guess. Okay, so on this one, I do see a number that stands all by itself, -40. So that is your constant term. So I see that x to the 3rd has the highest exponent of all 4 terms, so it's my lead term. So the degree is 3, and x to the 3rd is preceded by an understood 1. So 1's my leading coefficient. If it's to the 3rd power, if the degree is 3, I call it a cubic. So degree 1's linear, degree 2 is quadratic, degree 3 is cubic. Okay, so on the next one, 1, 2, 3 terms, trinomial. No plain number, so leading constant term is 0. X to the 5th is my largest exponent overall, so 2x to the 5th is my leading term. 5 then is my degree, 2 is my coefficient. And again, 1st degree is linear, 2nd degree is quadratic, 3rd degree is cubic, 4th degree we'll get to, 5th degree is quintic. All right, next one, -4x squared, -9. That's 2 terms. That's a binomial. I do have a plain number, -9, so that's my constant term. Negative 4x squared is my lead term, so it's written in the correct place. It starts out the problem. So 2 is my degree. Negative 4 is my coefficient. Since the degree is 2, this guy is quadratic, which means if I put a y equals in front of it, I would know exactly how to sketch that parabola. Remember, if I said y equals negative 4x squared minus 9, I can see that this guy would go down 9 and be upside down parabola. All right, last but not least, I see negative 8x to the fourth, 12x, and minus 6. 3 terms is trinomial. I do see a plain old number of negative 6, so that's my constant. It's written in the correct order because I've got x to the fourth, then x to the first, then an x to the 0 understood. So negative 8x to the fourth is my leading term, making 4 the degree, and negative 8 the constant term, or the leading coefficient. I'm all over the place, sorry. Now, fourth degree is quartic. So let me say that again. First degree is linear, second degree is quadratic, third degree is cubic, fourth degree is quartic, fifth degree is quintic. After that, you just say 6th degree polynomial, 7th degree polynomial, 8th degree polynomial, and on and on. All right, so it's more common that you only have one letter in the problem, but if you have a polynomial expression like we do here that has mixed letters, we can still talk about degree. So you need to get the degree of each individual term, and you do that by adding exponents. So look here, 2 plus 8 is 10. And so I'll remind you that I did 2 plus 8. I normally don't write that out, but since it's video, that might make it more clear to you. Here, look, x to the first, y to the fifth. 1 plus 5 is what I'm thinking. So the degree of this is 6. Here it's 3 plus 1 is 4. Here I see 4 plus 2 is 6. And the degree of this term would just be 0, because it would be as if there was an x to the 0, y to the 0, which you know x to the 0 is 1, y to the 0 is 1. So if there's no x or y, the degree of the term is 0. Now, what's the highest degree overall? 10. So the degree of the polynomial always goes with the highest degree of any individual term. So let's practice a little bit more. Get ahead of me on this. I'm going to give you 3 seconds. What's the degree of 2ab squared? If you said the degree is 3, you're correct, okay? Because I would say a to the first, b to the second, 1 plus 2 is 3. Now, what's the type of polynomial based on the number of terms? If you said monomial, you are correct. Now, you could kind of call it a cubic, but usually we don't really talk about linear, quadratic, cubic, quartic, quintic unless it's all one letter. Like if it's just got x to the first, x to the second, x to the third. We don't normally talk so much about those other degree names if it's a mixture of letters. So I'm not even going to worry about that here. All right, take a look at this one. Can you figure out the degree of this second polynomial? If you said 4, you're correct, because 2 plus 2 is 4, a to the first is 1, b to the third is 3, 4 is highest. Okay, go to your leading term. The leading term is the one that gave you to the fourth power. So what is your leading coefficient? Also 4. Now, what type of polynomial is it? Not by degree, because these are mixed letters, so you don't really get into the whole cubic, quintic, quartic thing. What's the type of polynomial by number of terms? Trinomial. 3 terms total. All right, try to get ahead of me on this next one. What's the degree of the polynomial? If you said 8, you're correct. Okay? The degree of this first term is 6. The degree of the second term is 3. The degree of the third term is 8. and the degree of the final term is 3. So 8's the largest. Since this is where the degree comes from, that's your leading term. So what's your leading coefficient? 3. I hope you got that right. So that's just a quick review with mixed letters. Normally we don't have mixed letters, but that is something that you need to know the vocabulary for, but it's not something that we'll be focused on as much throughout the chapter. So what we're going to do now is we're going to rewrite these polynomials so they're in the correct descending order. So let's go ahead and do that. Now on this first one, I see that negative 4x to the fifth should go, negative 4x to the fifth should go first. And then plus 3x cubed should go second. And then plus 6x squared minus 2x plus 8, those are in the right order. So just the first two were in the wrong place. Now on the second one, I see that the largest is 7x to the sixth. The next largest is 8x to the fifth. Let's see here. Then we drop to negative 2x cubed. So then I have plus 2x squared. And then I have minus 9x. So that's 1, 2, 3, 4, 5 terms. 1, 2, 3, 4, 5. I want to make sure I hadn't accidentally skipped one. So I'm just arranging them so the exponents go from the highest to the lowest as you move from left to right. Okay, name the leading term. So now that I've got things in order, the leading term is easy. On this first one, the leading term is negative 4x to the fifth. And the leading term gives you the degree and the leading coefficient. So I'll say the leading term here is 7x to the sixth. Then it says name the leading coefficient and the degree. So leading coefficient remember, a coefficient is the number that comes before your x's. So the leading coefficient's negative 4. So I'll say the leading coefficient, you'll see me always abbreviate it LC. On the second one, 7. And then what else can you tell from the leading term? The degree. So what is the degree here? Well, x to the fifth. So 5 is the leading coefficient, or 5 is the degree. And here, the degree, and again, you'll normally see me abbreviate DEG. Since it's 7x to the sixth is the degree. Now, I'm going to add something in that you'll see later. It's not going to be on your homework yet, but I want to kind of go ahead and expose you to this. All right, so when you graph these, let me give you a quick overview, and then I'll erase it. If it's linear to the first power, it's either a line that goes up or a line that goes down. Okay, it takes on one direction. If it's quadratic, all right, it takes on, because it's degree 2, two directions. So either it goes down, up, or up, down. That's 2 total directions. If it's cubic, that's third degree, so the graph will go in 3 directions. So it'll go up, up, or down, up, down. If it's quartic, that's 4th degree, so it'll go in 4 directions. So it'll either go down, up, or it'll go up, down, down. Now, what we won't know at this point is exactly how low or how high to make the tops and bottoms of the waves. That's something that develops over a couple of years. But right now, I just want you to get kind of a basic shape idea. Well, on this one, since the degree is 5, it takes on 5 directions. So it's either going to go 1, 2, 3, 4, 5, or it's going to go it's going to go 1, 2, 3, 4, 5. So how do you know which way? Is there a way that you can tell? Yes. If the leading coefficient's negative, then the right hand end is down. So let me say that again. Since you've got a negative leading coefficient, then you've got the right hand points down. So it's this option, not the other option. Okay? So now take a look at this next one. It's 6th degree. So it's either going to go 1, 2, 3, 4, 5, 6, or it's going to go 1, 2, 3, 4, 5, 6. Notice I'm being crazy with how high and how low I'm making the tops and bottoms of my waves. It's because I can. The older you get, the more you see, the more you'll learn about exactly how high and how low the waves go. This year, you get to have some fun with it. So which is it? Since the leading coefficient's positive, the right end goes up. So it's got to be this one, not the other one. So the other ones were a possibility, but then I can eliminate one of the two possibilities based on leading coefficient. So the leading coefficient tells you what's going on with the right end of the graph. So let's zip through on these. So I'm going to say I've got 4 terms here. X cubed first, 5x squared second, minus 3x third, and plus 10 fourth. On this one, let's see here. Negative 1/2 x to the fourth is in the right place. Minus 2x squared plus 3/4 x plus 1. So now I've got my exponents going from high to low. Now the exponents cannot be fractions, but your coefficients can. You can have any numbers as coefficients, but not any numbers for exponents. Exponents have to be 0, 1, 2, 3, 4, 5, 6, and higher. All right, so leading coefficient or leading term. Now that I've got this thing in the right order, the leading term is x cubed, and the leading term here is negative 1/2 x to the fourth. Degree and leading coefficient. The degree on this one, since it's x to the third, is 3. The leading coefficient, since it's 1x to the third, is 1. The degree on this one, since it's negative 1/2 x to the fourth, the degree is 4. The leading coefficient is that fraction, negative 1/2. Let's figure out how to graph it. So I see here it's a cubic. Cubic is degree 3, so it's either 1, 2, 3, or it's 1, 2, 3. Which one is it? Okay. Since the leading coefficient's positive, the right-hand end is up. So this is the answer for the graph, not that one. So on the next one, let's see here. The degree is 4, so it's a quartic. So it either goes 1, 2, 3, 4, or it goes 1, 2, 3, 4. How do I know which one? I look and say, oh, look, the leading coefficient's negative, which makes the right end down. All right, so this is the one, not that. So again, you're not going to have any graphing yet, but if you start to put that together now, you'll be happier. All right, so the rest of this is going to feel like something I know you can do because you did this kind of thing in Algebra 1, okay? Combining polynomials simply means add and subtract. How do you add and subtract polynomials? Add and subtract like terms. So on this one, if I start out and say, all right, let me start out with anything that has just a plain x squared. Okay, so I see 3x squared and 8x squared is 11x squared. Next, let me go to anything that has just an x. So I see 4x minus 3x is 1x, so plus x. Next, let me look at anything that has just a y. I'm not seeing anything else with just a y, so that one stands alone. Next, let me look at anything that has a y squared. So 6y squared and 5y squared is 11y squared. Last but not least, I'm just going to put my plain number at the end, so minus 10, and there we go. Now, don't worry, especially when it's got multiple letters. The order that you write it in is not quite as important, okay? It is when you've got a single letter, but when you've got mixed letters, don't try to rearrange it in the descending order. So don't make it harder on yourself. So now on this one, I'm going to drop the parentheses. Well, the first one, I'm multiplying by an understood 1, which doesn't change anything. So if there's just an understood positive 1 in front of the parentheses, just drop the parentheses. On this one, I have an understood negative 1 that I need to distribute, okay? So I'm going to say negative 1 times 2x squared. Negative 1 times positive 4x is negative 4x, not 4x, but 4xy. Negative 1 times 3y squared is negative 3y squared. Now we're going to do what we did a minute ago. So again, I've got mixed letters. Don't get too hung up on what order you write it in. Let me gather all my x squared terms. I see 2 of them. So 1x squared minus 2x squared is negative 1x squared. Let me gather all my xy terms. So, I'll do it down here. That was stupid of me to do it up there. So negative 5 and negative 4 is negative 9xy. Let me gather all of my y squared terms. No, I keep putting it up in the top instead of in the bottom. So looks like 10y squared minus 3y squared is plus 7y squared. And there's your answer. That's actually a typical way you'll see these written, is the x's kind of go from high to low, and then the y's, you'll have the crossover term with x's and y's, and then you'll kind of build up from low to high on your y terms. Don't worry about that. Don't worry about order so much unless you've just got x's. All right, so we're going to start and do the same thing. The first set of parentheses has just an understood plus 1 in front of it, so just drop the first set of parentheses. They're unnecessary in the problem. Now, the second set of parentheses has the negative 1 right here, so that means you've got to distribute. In other words, flip-flop all the signs. So x to the 5th goes to negative x to the 5th, minus 4x cubed goes to positive 4x cubed. Then I'm going to get minus 8x squared, minus 11x, and plus 1. So when you're subtracting, you're distributing a negative 1, which has the effect of flip-flopping all the signs to their opposites. Now I'm going to start to put things together. Do I have any more x to the 5th terms? I do. So 6 minus 1 is 5x to the 5th. Now on this one, I will attempt to put it in descending order because I've got one single letter. So that's kind of the way we handle it. So 3x to the 4th, do I have any more x to the 4th terms? No, I do not. So let's see here. Minus 2x cubed plus 4x cubed is plus 2x cubed. So now I'm going to go into my x squared terms. So I've got x squared minus 8x squared is minus 7x squared. And then I've got my minus 5x minus 11x. When I add those, I get minus 16x. And then I've got my plain numbers on the end. So minus 7 and plus 1 is minus 6. So pretty straightforward, don't you think? I would say that you'd think that this is pretty all right. So on the next one, we're going to start out and say, well, I can't just drop parentheses. I have to distribute, right? So you're going to have to do this on both of them. All right, well, no biggie squiggy. You're going to be fine doing that. So let's see here. I've got 21 x to the 4th. 3 times negative 2 is negative 6. X cubed. 3 times negative 9 is negative 27. 2 times x to the 4th. 2 times 3. 2 times negative 6. 2 times 8. And my distribution's done. Now I'm going to collect like terms. I scan and notice that my highest exponent is x to the 4th. So put those first. I get 23. When I scan, I notice that next is x cubed, negative 6x cubed, and positive 6x cubed. Woohoo! Those just cancel out. So I don't have an x cubed term. All right, got that. Then I've got, I should have x squareds next. I do have an x squared, so negative 12x squared. Let's see here. I should have an x. I do, plus 16x. And last but not least, my plain numbers minus 27. And I'm done. So these are kind of bright and happy colored, aren't they? All right, so on this one, guys, we're just going to find the perimeter. So this is the same thing about combining polynomials. We're just going to add on some basic stuff we know. So if this is a rectangle, you know the top and the bottom have to be the same length, if this helps you. And you know the left and the right have to be the same length. So I've left room for you to label, but I'm not convinced that you even have to write all that out. I bet you could skip that. Because don't you know that the perimeter means the sum of all four sides. So you could either say the top plus the bottom plus the left plus the right, or you could say 2 times either the top or the bottom plus 2 times either the left or the right. And I bet that you'd like that better because it's going to be faster to work out. So my perimeter is going to be 4x. I'm distributing 2. Plus 2 times 3 is 6y. 2 times negative 5 is negative 10xy. 2 times 10 is 20. 2 times 6 is 12. 2 times negative 1 is negative 2. 2 times 3 is 6. So my perimeter is going to be, let's see here, 4x. Do I have any other x's? Minus 2x is 2x. Plus 6y. Do I have any more y's? Plus 6y is plus 12y. Minus 10xy. Do I have any more xy's? I do. So minus 10 plus 12 is plus 2xy. And then plus 20 on the end. That'll be my caboose. And I'm done. All right, there's nothing else to do. So if it wants an expression, then the only thing that you're going to enter is this expression. You don't have to say P equals. So remember, expressions means don't put in equal signs. When you put an equal sign, you've got an equation. I believe that's it. So today's assignment is the MML. It looks long, but you're going to find it's not going to take you that much time because the vocabulary questions are super short.